Hello everyone. What we're going to focus on in this video is how to use the sine of an angle ratio to calculate the measure of an unknown angle in a given right angle triangle. So here I have a right angle triangle and we know two lengths and we want to calculate an unknown angle, which is theta in this case. So the first step is to label your triangle according to angle theta, which is in question here. So if you draw a line from angle theta going to this side, it will take you up to where 35 centimeter is. And you will note that this side would work out to be what we call the opposite. All right, because it is opposite to this angle. If we draw a line from this 90-degree measurement, it will take us to this side where 37 centimeter is, and that would be the hypotenuse. Based on the information that we have an opposite length, we have a hypotenuse length, and we have an angle that is opposite to that length. Therefore, the most suitable ratio is going to be the sine of an angle ratio. So therefore, sine theta is equal to the opposite length divided by the hypotenuse length. Now, all you have to do is to substitute the values from the diagram. So we can see that sine theta is going to equal to the opposite length, in this case that was 35, divided by the hypotenuse length, in this case that was 37. Now all you need to do is to divide 35 by 37. So you note that here we'll have sine theta is going to equal to 0.946, correct to three significant figures. All right. Now, in order to determine the angle, we have to use the inverse function. So at this stage, what you're going to say is to say that theta is going to equal to sine inverse of 0.946. And all you need to do is to type that in your calculator. So when you type this in your calculator, your expected answer is going to be 71.1 degrees. So therefore, theta is equal to 71.1 degrees. And that's how you use the sine ratio to determine an angle. All right? Let's look at our second problem. Here, we want to determine what angle x is. So we're going to label the triangle according to angle x. So if we draw a line going down here, it goes to the side that has 13 centimeter. That would be our opposite side, right? Because this side is opposite to the angle in question. If we draw a line from the 90 degrees angle going towards this side, it takes us to the longest side, which is always the hypotenuse. All right, so 21 is going to be the hypotenuse length. And again, the most suitable ratio is going to be the sine ratio, because sine theta is equal to the opposite length divided by the hypotenuse length. Now, what is theta in this case? Theta in this case is just x. So it's going to be sine x degrees, which is the unknown which we want to find, is going to equal to 13, because 13 is the opposite length, divided by 21, because 21 is the hypotenuse length. Now we can work down the decimal for 13 divided by 21. So 13 divided by 21 as a decimal is going to approximate to be 0.619. All right. So we know that sine x degrees is equal to 0.619. To determine the angle, again, you're going to take the inverse function. So we can see that x degrees is going to equal to sine inverse of 0.619. All you need to do is to type this on your calculator, and your expected answer is going to be 38.2 degrees. And that's it. Now for the final question here that we're going to do for this video, we're asked to find theta again. Label our triangle according to the angle in question. So if you draw a line from theta going to this side, it will take us to the side that has 5 centimeters. That side is opposite to the angle theta. All right. We draw a line from the measure of the 90-degree angle going to this side. It gives us the side that has 9 centimeters, and that's going to be the longest side, which is the hypotenuse. So again, the ratio to determine this angle is going to be the sine of an angle. So we can write that out. We know that sine theta is going to equal to the opposite length divided by the hypotenuse length. We know that sine theta is going to equal to, what's the opposite length? The opposite length here is just 5. So that's why it could be 5 divided by the hypotenuse length, which is going to be 9. All right. So we can see that sine theta is going to equal to 5 divided by 9. 5 divided by 9 as a decimal is going to work out to approximately 0.556, correct to 3 significant figures. Now to determine the angle, we need to use the inverse function. So here, theta is going to equal to sine inverse of 0.556. All you need to do is to put this on your calculator. When you do that, your expected angle is going to be 33.8 degrees. And that's it. Thank you very much for watching, and do enjoy the rest of your day.